So about exponentials and logarithms. So we're going to talk about their function, like their graphs basically. By the way, this chapter, functions, is supposed to be, I would personally say, one of the most difficult things. Because not because it's a very difficult thing to understand, but because there's a lot of different things that they can ask you. Okay. So this being one thing, like making a new function and then asking you a weird question like that about it. So make sure that you guys are doing this homework, and if any question does not appear obvious, let me know, okay? Also, I just realized that you guys don't have anywhere to check these answers. I don't know if these things have mark schemes in them. One second. Um, just a second. That About exponentials and logarithms, like if you know functions, like if you're generally familiar with how functions work, how the input works, how the output works, etc., then logarithms and exponentials are just another kind of function. So you don't need to worry about them like separately. But just like you're supposed to know like what the general graph of a parabola, sorry, of a quadratic looks like, etc., and you know how to draw the graph of a linear function, for example, you also need to have a rough idea on how to draw the graph of an exponential. Okay? What is an exponential? An exponential function is any function where the variable is in the power. Okay? So they will normally come in this kind of form. So you see a constant, which is the coefficient, and then you see another constant, which is the base, and then you see a variable on top. Okay? So for example, you have 2 times 3 to the power of x. What is this 2 doing here? He's basically a coefficient. He doesn't have a power of x on him. He's just sitting there as a number. We call this guy the coefficient. We call this guy the base, and this is the exponent. Hence the name exponential. Okay? Now, the important thing to remember is that the graph of an exponential looks like this, always. It has a horizontal asymptote right here, and it grows like this. Okay? If the power of x, if b is a positive number, okay? If the base is positive, not if the base is positive, I mean if the variable is positive. So if you have like b to the power of x, it's going to look like this. And if the base is negative, if the exponent is negative, it's going to look more like this. Okay? Now, so again, if x is positive, you're going to have a growing exponential. If x is negative, if there's a negative attached here, it's going to look like a decaying exponential. This is not very important, by the way, for you to remember, because again, you can just plot them. But you should generally remember, like, just have a rough idea of this so you don't have to plot every time you have a question. Um, One thing to remember is the bigger this number, the quicker the exponential will grow. For example, if b is bigger, it's going to grow quicker, like this. Okay? Another important thing to remember is, let me actually ask you guys a question, right? So for the y-intercept, if I give you any exponential in the world, like a times b to the power of, no, actually no, like, I don't know, 4 to the power of x, can one of you tell me how I can find the y-intercept of this function? The rule is the same every single time. The method to find the y-intercept of any function is the same always. What is it? Come on, guys, this is from 2 classes ago. How do you find y-intercepts? Amy, Jessica, Sophia, anybody? Give me an answer.
Sorry, I'm just looking for a quick.
You shouldn't have to look for something this obvious. The y-intercept is always found by just plugging in x as 0 and finding y. It's always the same. You should not have to check your notes for this. Okay? And same for x-intercept, you need to plug in y as 0 and find x. Okay? So for y-intercept, plug in x as 0 in your function and find y. So If I plug in 0 for x, what will this become? Can somebody tell me?
Is it 4 to the power of 0?
Which is? What is
Zero.
anything to the power of 0?
1.
1. Which means that the y-intercept of every exponential is always 1 because you gotta plug in x to be 0, and the thing is whenever you raise something to the power of 0 you get a 1. So the y-intercept is always 1. So no matter how fast it grows, it's always gonna pass through the same y-intercept. Okay? Even if it's a slow growth, it's gonna pass through the same y-intercept. Okay? So, for example, if you have 4 to the power of x, it's going to be a fast grower. If you have 2 to the power of x, it's going to be kind of slow. If you have 0.5 to the power of x, it's going to be even slower. Okay? But the point being, it's always going to be like growing with a decreasing rate, basically. But it'll always pass through the same y-intercept. Okay? That's basically the general idea. Now let's look at a few quick questions. So, for example, this one. So we have a function, clearly an exponential. Can anybody tell me why this is an exponential function? Why am I calling it an exponential function?
Because it has the to the power of x.
Yeah, because x, the variable, is sitting in the power. That's why it's an exponential. Now, write down the, okay, write down the coordinates of the y-intercept. Can somebody tell me how I can find the y-intercept without checking their notes, preferably?
You plug in 0.
For what?
The fx.
No, you plug in 0 for x, not for f of x.
Oh yeah, that
Yeah, if
thing.
you plug in 0 for f of x, that's essentially you saying plug in 0 for y, because f of x is y. For y-intercept, plug in x to be 0 and find y, which by the way means the same thing as find f of 0. So f of 0 is obviously going to be 1. You don't even need to do the calculation, that's why it's 1 point. It's always going to be 1. Now, write down a in decimal form. Okay, now it says that a is a point with the x value of -1 and y value of a. Okay, how can I find the value of a? Sophia, what do you think? If I tell you that the x value is -1 and I want you to find the y value, which is written as a for now, how do I find that value?
You just plug it into the equation.
Okay, how do I do that? Plug
And
what in where?
f in brackets -1 is equal
Exactly.
to 4
So we
to the
have
power
4 to the power of -1, which is, does anybody know mentally what this would be?
of
4 to the power of -1 means 1 over 4, a quarter,
mm,
which means 0.25.
yeah.
So write down the values of b and c. I assume that you guys have understood the idea and you know how to find b and c, right?
hmm Yeah.
Right? Plug in 1 for x and find b, find the y value, and plug in 2 for x and find the y value. Write down the equation of the horizontal asymptote. Common question. So, does anybody remember where is the horizontal asymptote of an exponential? Not the equation, just where it is. Anybody? The y-intercept of a exponential is right there at the x-axis. See, the as you can see, all of these exponentials do not cross the x-axis. They kind of just die out at the x-axis, but they never cross it, which means the x-axis is the asymptote, which means there's a line here, which is the asymptote. Now, what's the equation of this line? How do I write down the equation of this line? Anybody? How do you write the equation of horizontal lines? Come on, guys. This is supposed to be obvious knowledge at this point.
X equals 0. I don't know. No, y equals 0.
Y equals 0. Good job. You were about to be told that you're wrong, but you're repaired. Good job. Y equals 0. Why? Again, I've told you this already, but for horizontal line, you're essentially thinking about the only place on one of the axes that the line crosses. Okay? For example, if you say y equals 2, that means that the line only touches y equals 2. That's why it's a horizontal line. If you said x equals 2, it would look more like this line, which is a vertical line. Okay? I know it's a bit confusing because x sounds like it should be horizontal, but math is not very nice sometimes. Okay, on the graph, on the diagram, sketch the graph. This is pretty easy. Just, I mean, if you're completely lost, you can still sketch it because they gave you a bunch of points. But you guys should know that you should not, absolutely not, like you should make it very obvious that your graph never touches the x-axis. That's what they're kind of tricking you into. They drew this point here because they want you to touch the x-axis. The moment you touch the x-axis, you're losing a point, maybe even two. Right, now with everything you know about exponentials, can anybody tell me what the domain of an exponential is? Do you guys remember what the, sorry?
Would the domain be on the x-axis?
Yeah, so basically all the x values that the function touches or can take. Any idea? It's very easy, by the way. All you have to do is just look at the graph. Which,
-4 and 4.
so do you think that the graph ends at -4 or do you think it keeps going forever? Because there is no restriction, is there? I never said that it has to stop here or there. So it's actually minus infinity to infinity because x can be anything it wants. You can plug in any x value. It also makes sense, by the way, because this function, no matter what you put as the power of 4, nothing, like you can put literally anything. The range is where it gets a bit more fun. What are all the possible output values, y values, that the function can take? So what's the lower range, lower bound of the range?
Is it not 0?
Do you think I can include 0 or do you think I should say something like not including 0 but anything above 0? Like, should I include 0 in my range? Or should I not include 0 in my range, basically? I should not.
All real values.
No, it can't be all real values because if you said all real values, you would include the negative ones. But the exponential never crosses the x-axis. So it's definitely something to do with 0, the lower bound. But is it more than 0 or is it more than or equal to 0?
More.
Exactly. It can't be equal. It never touches the x-axis, which means it never really becomes 0. So y is more than 0. And what's the upper bound? Would you say it's 20?
No, it keeps going.
Exactly. I tried to trap you. Sophia's too smart for me. Okay. So the domain is this. I mean, I don't know why I wrote them in two different ways, but there, that's better. So that is basically a kind of a common question you can get about exponentials. Now, that basically ends our discussion on functions, which is nice. We can move on now to trigonometry and like geometry and stuff like that. I'm sure that is one of your most favorite topics, right, guys? Yeah. So the good news is that we're basically 50% of the way through this whole course. I know that some of you might be thinking we have done very easy questions compared to what shows up in the exams. But that's the thing. If you're struggling on any easy question, that means that you will absolutely not be able to do the tough ones, right? So the goal right now is for me to make sure that you guys are good at your basics. That's why I'm telling you, do this homework, do the homework I gave you, check your answers. Anything you get wrong is supposed to be like communicated to me so that I can tell you guys how to do it right, and like kind of maybe even kind of polish the knowledge on that idea. So make sure when you're doing the homework, your idea, your mentality is, I hope I get something wrong. So, it doesn't go hidden. Because if you don't find out don't know something and the exam comes, and then it's a bit of a tense situation. All right, so next up we have trigonometry and geometry. Let's